Hello everyone, welcome to another video for Mathematics of Grade 9. In this video, we are going to study Chapter 5, Section 5, which is about parallel lines and proportionality. This section is just a continuation of the previous section. So in Section 4, which was about similar triangles, we developed pretty much everything about the concepts of similar triangles. We had the important postulates to show that triangles are similar, and so this section is just contains a few theorems that are basically a continuation of what we had in Section 4. So let's see the first theorem, which is about triangle proportionality theorem. So it says, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So just take a look at this triangle here. Let's say you have a triangle, okay, and a line comes and intersects these two sides, which this line is parallel to this line, to this side of the triangle. Okay, so this line parallel to this side. Then it says it divides the sides proportionally. Proportionally, that means this AF over FC is equal to AE over EB, as you see over here. Okay, before we solve a few examples, I'm going to prove this conclusion for you. I'm going to prove this, why this holds, why AF over FC equals AE over EB. So in order to prove this, I will get you back to the previous section, Section 4. If you remember, we just had a question like this, something like this in Section 4. We had a triangle, or more accurately, we had two triangles like this, right? This one and this one. This side was parallel to this side, so this triangle was similar to the bigger one. So the small triangle over here is similar to the bigger triangle, right? Because of AA, right? This angle equals that angle, and this angle equals that angle, and angle A is the common angle. So this little triangle on the top is similar to the bigger triangle. So we can write down the things that we had in Section 4. So what we have there? It was AF from the smaller triangle over AC from the bigger triangle equals AE over AB. That's what we had, right? So let's write it. AF, I'm going to write it here, over AC equals AE over AB, right? So AF over, but if you look at the AC, side AC is just AF plus FC. So let's replace AC by AF plus FC. So this is equal to AE over, in the same way, AB is AE plus EB. So let's replace this by AE plus EB. Now I'm going to reciprocate both sides. So it's AF plus FC over AF equals AE plus EB over AE. And now I'm going to divide. So I'm going to divide this by this one and this by this one. It becomes, so if I divide AF by AF, the answer is 1, then plus FC over AF. So it's 1 plus FC over AF equals, same thing happens on the right hand side, 1 plus EB over AE. Now those two ones, they cancel, so what remains is FC over AF equals EB over AE. And now I can reciprocate again, which is AF over FC equals AE over EB, which is the same thing that you had over here. So that was just the proof for this proportionality theorem that we had here. It's not a big deal, so I'm just going to erase this proof. I just wanted to show you why this happens. And now you have to memorize the result. So AF over FC equals AE over EB. So whenever this line is parallel to this one, we have this proportionality. AF over FC equals AE over EB. Okay, so now let me erase the proof. And let's solve some examples for this one. Okay, so example, find CY, find the length of CY in this triangle. So CY is here, that's CY. So again, see, we are in a similar situation like this one. There is a triangle here, this line is parallel to this side, and therefore the sides that we get here are proportional. So AY over YC equals AX over XB. Let's write the proportionality. For convenience, I'm going to call this CYX. Let's call it another variable. Let's call it little y. Okay, so let's find the value of y. AX over XB, this is equal to AY over YC, so those are all length. Now let's replace AX is 9, XB is 4, equals AY is 10, and YC is Y. We are going to find this one. So cross product, 9y equals 40, which means y equals 40 divided by 9, and that's the value of CY. Okay, so next theorem that we have here is converse of a triangle proportionality theorem. So this theorem is sort of the converse of the previous theorem. In previous theorem, so let's just read the theorem here. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So remember, in the previous theorem here, if this line is parallel to this one, then we have AF over FC equals AE over EB. Now, the converse of this theorem, it goes like this. If a line intersects two sides of a triangle, like this, so we don't know if this is parallel to this one or not. We don't know yet. It says if this proportionality holds, if AF over FC is equal to AE over EB, then we can conclude that this line must have been parallel to this line. So that's the conclusion. Okay, so if we have the proportionality, then this line must have been parallel to this one. That's what this theorem tells us. So how can we apply this theorem? Just take a look at this example. It says verify that the line MN, this MN, is parallel, so that's the notation for parallel, to KL, to this one. It says prove or show or verify that MN is parallel to this one. So all you have to do here is to just use this converse of triangle proportionality. If 30 over 15 equals 42 over 21, then we can conclude that MN is parallel to this one. So let's just write down the proportionality and see if that holds. So let's check this one. Jn over NL, is this equal to, so I'm going to put a question mark here, is this equal to Jm over Mk? Let's replace the values. So Jn is 30 over 15. Is this equal to 42 over 21? So 30 over 15 is 2, and 42 over 21 is also 2. So is 2 equal to 2? Yes, it is. So because we have the proportionality, so Mn must be parallel to KL. So those two lines are parallel to each other. Okay? So that's how we apply converse of triangle proportionality theorem. One last example for this video. It says find DG. So DG is this side over here, this part. We have two triangles. This one is parallel to this one. So we can use the first theorem. EC over CF equals ED over DG. And then we can find the length of DG. So let's call DG X and write down the proportionality. So EC divided by CF, this is equal to ED divided by DG. Let's replace the values. EC is given by 32, CF is 24, ED is 40, and DG is X. So let's cross product. 32 times X equals 40 times 24. So 32x equals 40 times 24 is 960. So now we divide 960 by 32. 960 divided by 32. So it's going to be 30. So x is 30. And now if you look at the numbers here, that kind of makes sense. So if your answer, if you got, I don't know, if you got 6 or 5 or 7 for x, then that would be wrong, because you cannot have a 6 or 7 here while you have the numbers like 24, 32, and 40 here. So whatever number you get for x must be very close to these numbers. So in this case, it's 30 and everything is okay.